Hello everyone, this is the video for lesson 2.5, solving systems of equations using graphing. There's going to be a couple of things that we're going to do today. We would be able to describe what a nonlinear system is, and we are going to solve systems using graphing. So we'll either be given a graph or we will graph using Desmos and find the intersection points. Okay, so what is a nonlinear system? That is a system of equations that has at least one equations that's nonlinear, which basically means it's not a straight line. So let's see what it looks like. We've got a parabola, which is a quadratic equation, and a linear, which is a straight line. So the black line is linear and the blue curve is nonlinear. Notice that you have three different possibilities. If they do not intersect, you're going to have no solution. If they intersect at one place, then you will have one solution. And if they intersect at two places, you can have two solutions. So this is very similar to what we did in the past, except for when you have one equation, you are looking for the solutions on the x-axis. But if you have two equations, then you're going to look to see where they both intersect. So in the second different category over here, we have a linear black line and we have a blue circle. So this is a nonlinear system. No intersection points means no real solution. One intersection point is one solution. And two intersection points would be two different solutions. And I just want to make something clear that if you have one equation, the solutions will be on the x-axis. But if you have more than one equation, it is where your graphs intersect. So the solutions are going to be where your equations intersect on the coordinate plane. And you're always going to write the solution as a coordinate pair. So it will look like x and y coordinate, not just the x. So a common notation for solving a system of equations is going to look like this. If it's written in function notation form, it'll say like f of x is equal to g of x. Solve the system. Or it may not even say solve the system. It'll just say find where f of x is equal to g of x. It's just AKA solve, find where they intersect each other. So let's take a look at three examples. I have a quadratic equation and a linear equation. You can see right here, we're going to highlight where they intersect. Notice how I do not care about the x-intercept. So x-intercepts are solutions for one single equation. If you're going to do a system, so a system is more than one equation, the system will be where they graphs intersect. So you've got two solutions here. And a lot of times they're going to be decimals, so you're going to have to round them, which is perfectly fine. Here we've got a linear equation and a circle. And I'll show you what a circle looks like in a minute, but it only intersects in one place, which means it's got one solution at 3, 1. And then over here we have a linear function with a quadratic function, and they do not intersect. So that would be a no solution. All right, let's practice our skills. So it says use the graphs to solve the system of equations. So system means I'm looking for intersection of the two graphs. Notice how these two graphs do not intersect. So that means we have no solution for this first set. Over here, it looks like I have one intersection point here. And if I just count 1, 2, 3, that's going to be at 0, 3. I have one solution, and that solution is 0, 3. And then over here, it looks like I've got two places. Now, it does connect at the x-axis, but it has nothing to do with that. It's just where the two come together, here and here. So this one is over 2, up 4. And this one is left 2, up 0. So I have two solutions at -2, 0. And 2, 4. Notice how I write both the x and the y coordinate for the solution to a system of equations. All right, so what are we going to do when it asks us to solve or to find out where does f of x equals g of x and we don't have a graph? We're going to use technology, okay? Technology is by far the fastest, quickest way to do this. So we're going to type in each equation. Okay, notice how if it is quadratic, it needs to be either equal to f of x or y. If it's linear, or if it's a circle, everything will work. I don't know why Desmos does that, but the second one is linear, so I don't have to really worry about anything. But let me scoot this over so you can see it a little bit better. Here's what we're going to do. You're going to locate where they intersect. You're going to click right here. And we are going to copy this sketch over to our notes. And I'm going to flip back over here and we're going to do it in a second. All right, so here's how it works. Nope, you don't even need an X and Y axis. So here, and I already forgot what it looks like. There we go. So this hit at 5, 3. And this hit at 0, -2. See, you don't have to do an X and Y axis. You don't have to do any tick marks or anything like that. Just generic shapes. You got your quadratic. By the way, we're going to label this quadratic. And this one's going to be linear. Okay, it's important for you to know the families. And then just write down the two solutions. So that's all you got to do. All right, so let's look at question number 2. All right, so question number 2, this one right here, notice how it's x plus y, it's not x squared. That is linear. If it's linear, anything will work. It can be equal to anything. See, it graphs it. It's amazing. Second one, though, is quadratic. See how it says x squared? That's not going to work. What you're going to have to do is you're going to have to add 1/2 x to both sides. So I'm going to put y equals positive 1/2 x. I'm going to show my work in a second. X squared, and then minus 2x plus 4. And then, oh, okay. While I do have a solution here, that's just for the linear equation. I don't have a solution to the system because these two graphs do not intersect. So I'm just going to do like a generic little graph over here. So I've got this one, and then I've got my linear right here. It's just missing it, so I'm going to say no solution. And I'm going to show my work here on how I typed it into Desmos. Okay, and that's it. All right, let's look at the last question. Not sure if you notice it, but that one does not look like it belongs to anything that we've done this year so far, and it's because it doesn't. So you see how it's got the little x squared on it, but what about this y squared? So anytime you see x squared plus y squared, and they're all going to be like this, it's going to be a circle. So x squared plus y squared equals 4 is going to be a circle. You can type it in just like that. This last one over here, see how it's x to the power of 1? That is going to be a linear equation. So you can just go ahead and start typing them as they are in Desmos. And it's kind of neat what happens. So x squared plus y squared equals 4. There it is. That's a circle. And then we have y equals 1/2 x plus 1/2. Okay. Looks like I've got a couple of solutions here. And I'm just going to go ahead and pause this video. I'm going to copy it down to the notes, and you go ahead and copy it down to your notes too. And let's see what we get. Okay, so I have temporarily drawn a picture over here, but I need to click on this. And a lot of times we're going to have to round. So it looks like it's, let me scoot it over a bit, 1.5 and 1.3. So 1.5 and 1.3, and then let's go back over here. Woo! Now I've got negative 1.9 and negative 0.5. So negative 1.9 and 0.5. And those are my two solutions. And that is how it works. So just remember that if you are trying to solve a system of equations, it is not the x-axis, it is where they intersect, and it has to be both the x and the y coordinate is the solution. So you've got a few questions right here. This is going to go a lot faster than you think it will. A lot of these are graphs, and you can just look at the graph and write down the answer. And some of them you'll have to use Desmos, but it shouldn't take you very long at all. And as always, just let me know if you've got any questions.